At Dave Cooper Live, we connect the industry leaders in the architectural, engineering, and construction space with the people, the products, and the processes to help them build it better. All right, everybody, listen, today's an exciting show. We are live on location at Frametec in Camp Verde, Arizona. But before we get into that live walkthrough, first, a word from our supporting members. CombiLift is the largest global manufacturer of multi-directional forklifts and straddle carriers, a leader in long load handling solutions, offering a free warehouse and site optimization design service. CombiLift helps companies of all sizes and from every industry maximize the capacity, safety, and efficiency of their warehouse and storage facilities. A big thank you to Paul Short and the team at CombiLift for helping us all to build it better. Visit them at combilift.com. Ready to scale up your offsite construction business? Introducing 4A Constructs, your solution to finding skilled labor for offsite manufacturing. Say goodbye to the headache of recruiting a skilled workforce with hand-selected certified tradesmen that are expertly trained and managed for offsite manufacturing, set crews, and finish crews, ensuring maximum productivity and safety. Unlock the future of skilled workforce development for all of your offsite construction needs. Visit them at 4aconstructs.com. Hey everybody, this is Dave Cooper and we are in Camp Verde, Arizona, and staying with me is Josh Lewis, COO of Frametec. Josh, thanks for having us.
Thanks for coming, Dave.
Hey, listen, so we're out here for Advancing Prefab, and Josh was kind enough to say, hey, why don't you drive an hour and a half through the desert and come see the automation that we have at our manufacturing facility. And if you don't remember, Josh was recently just on the show, so Josh, tell us a little bit about what we're going to walk through and see here. And yes, we are doing this IRL style in real life.
So yeah, we're going to walk through what is the most automated component manufacturing facility in the United States today. And a big part of that is our patented material handling system. So we'll walk over there. That's where our process starts. And we'll show you how it all works and then walk through the rest of our fabrication stations.
Got it. So we're going to end up back here at this station on the way back, but you're going to take us through all the automation. Yeah. Let's do it. So tell us where we're going and walk us through.
So we're going to go over to Frametec's patented material processing center. So this is the brainchild of Marvin Phelps, who's a legend in the industry. Marvin's 82 years old. He beats me to work most mornings. He's had this thing in his head for better than 30 years. So this is one of one in the world. We partnered with Weinig on this particular system, and it does the lion's share of our component cutting. So everything for our walls, trusses, all is going to come off this line. So what you'll notice as we get a little closer is we have 5 automated in-feed bays, and most of your audience will know that you're going to typically give a forklift driver a pick list, and he's going to drive over throughout the lumber yard, and he's going to pick 8s to 20s, a whole bunch of pieces here or there, take it to your saw operator, put it on the live deck, and then they're going to handle those pieces one by one.
And that all starts here on this side, right?
Yep, over here. So you see here we have 5 in-feed bays. Each one of those in-feed bays can ingest any length of lumber from about 4 feet all the way to 16 feet. I am not limited by length structure anymore. So we can buy anything the mills are long on, the secondaries are long on. We're just after cheap fiber. And instead of our forklift driver running around the yard picking up pieces, all we do is load full units of lumber into the in-feed bays, and the system's going to take it from there. So as the system calls for this specific dimension and grade of material, the vacuum stacker comes down, grabs the whole layer off the top of the unit, puts it into the process, and then as the system is calling for footage, this thing is just going to continue to feed material in. So we can destack a whole unit in about 10 minutes.
So the equipment actually gets fed from that back garage
Correct.
door, I'm
Yep.
assuming, and
Yep.
it gets pushed in this way. And then what's going on is that top feeder up there comes down, picks it up, moves it into place
Correct.
as the system and the data is calling for it.
Yep. And then
Great.
as it's getting conveyed in, our first little QC touch right here, there's some orange rollers with some scallop bars, might be kind of hard to see. That's a board flipper, so we're scanning for crown as it comes in. If the crown's the wrong way, the flippers fire, flip the board over, and then inside that silver rail is another high-speed belt. That's going to take our material down to the QC cell at 320 feet a minute.
What's interesting is what you just said, and we talked about this earlier. Most framers do not know how to quantify the cost of what it takes for a person manually on site, always trying to flip and find a crown when lumber's dropped off.
That's right.
This is where the efficiency of automation comes in, and this is where site framers, in my opinion, need to really start paying attention to how time is spent. Even the littlest thing like finding a crown.
That's it, right? All those little things impact tremendously the finished products we're putting out. So letting the automation do some of those medial tasks and getting the level of consistency we can allows us to turn over a way better house. And it eliminates a ton of rework, not just for the framer, but for every trade that follows us. And that's where a lot of the waste lies.
I bet. So what are we coming into here?
So this is our QC cell. We have 3 different pieces of equipment in here. We'll walk around and kind of get a look back. The first one, right here to the left, is going to be the shape scan. So that measures every board that comes through for bend, bow, and twist. And then it moves through the shape scan through this little sensor here with the blue circle on it. That is a moisture meter. That ensures that our lumber has a moisture content of between 9 and 19%. And then it's going to go through this big optical scanner.
The optical scanner. So what is... Got it. So that's like going through an x-ray machine.
Basically, yeah. So that can scan for any visual defect in lumber at 320 feet a minute. So anything you can see with your eye, it can see, identify, and make determinations on whether or not that defect is allowed in our product. So anything from slope of grain to knot size to wane, end splits, all of that is scanned on the fly on all sides faster than you can walk.
What's the tolerances on that?
Very tight. Very tight. Yeah. We can, if you wanted me to build you a house with clear vertical grain lumber, no knots, no wane, we could do it. We could update our parameters. But because we're so stringent on our quality control, we're buying really, really high-end fiber. Now the length doesn't matter, but I'm buying from a couple inland mills that produce a better stick, and then we're QCing it again to make sure that the product that gets to our finished product is better than anything else you're going to see.
Got it. So everything's getting QC'd on this line coming through. Then where are we going here? Because it looks like we have almost like a scissor table or something back here.
Yep, so we'll walk around. That's going to go through our accumulation deck and the defect saw. So in the event that we're going to defect the board in its entirety, and typically that's a moisture content issue, it goes up over the top and gets put on a cart. Now we don't throw that away. Typically that's a high moisture content. It's over 19%, and what we're going to do is we're going to take that to our offline saws and process it there. By the time it makes it into the component, it'll be well under 19. Anything that's accepted is going to go underneath, and that's where we're going to move it through our Quantum 450 saw, and that's going to remove all the defects.
Quantum 450.
So as those boards accumulate, this saw knows in every stick where the defects are, within fractions of millimeters. As the board enters the saw will feed, fire, eliminate the defect, and then kick it out the other side. Now, in the instance we have a 16-foot board that is outside our criteria for bend, bow, and twist. What we're doing is we're optimizing that scrap length and we're making it into value-add product. So right now our scrap length is optimized to 22 and 7/16, and guys in the industry will recognize that. That's a common block length for anything 2 foot on center. So I'm sending out pre-cut blocks with all my truss packages, so we're not out there with a skill saw cutting up good material.
That's right.
After it clears QC, it's on this belt and it's going to run all the way through to that green stop. So now we have material that's been through our QC process, has been accepted, and we're going to run it down into our finger joint cell. So in this cell, there's 2 sets of shaper heads. We're going to cut our finger joints on both sides, and then we're going to go into our press and actually make Frametec's continuous or infinite board.
So explain that. When you say continuous or infinite board, what do you mean by that?
That means that we're literally extruding an infinite board. So if we needed to cut something that was 14-foot 1/4 inch, historically, that's coming out of a 16-footer.
Right.
You're dropping better than 2 feet in the trash. So what we're doing is we're extruding an endless board, and then we're cutting exactly what we need out of that infinite board. So if we need 14-foot 1/4 inch, we extrude 14-foot 1/4 inch and cut it. This eliminates 99% of the wood waste that you're going to see in a component factory like this. We're not.
So I'm not going to have dumps of 30% of lumber laying in a dumpster
Nope.
on my job site anymore, because you're cutting it specifically to the length that it needs to be.
Not only that, but if you go to any traditional component plant and look in their dumpster, they're going to have a lot of waste in those as well.
Yeah.
All that's eliminated. What we produce as far as waste is the event that we have to cut a knot or end split out of the end of the board because we can't put a finger joint in anything but good sound wood, and then the drop from a wedge, right? If we have to do an angle cut. That's the extent of it. That and sawdust. So
what's the longest board foot you've run out of here so far?
The longest board we'll typically run through this process is 20 feet. We can run up to 40 feet through our bypass deck. For, say, we have a floor truss that has a continuous bottom chord of 36 feet. We don't need to splice that off table, so it eliminates additional handling, a piece of equipment you have to have. We just extrude a 30-plus foot, 40 up to 40 feet, and slap it in the truss.
And with any waste that you do have, how do you reuse it?
It's right now it's just sawdust and wedges. So
that's it.
Yeah.
Perfect.
It's nothing. So we go through our 2 shapers. So it goes through the far shaper. We do our first finger, apply a water primer, sweep it to the front fence here. It goes through the second shaper, and then we're applying our Hinkle Loctite PUR adhesive. And then from there, we have a board with finger joints on both sides, glue on one, primer on the other. It goes into the threading unit, which is the first half of this. And that's where we're loosely aligning those joints, getting those boards straightened through a series of chains. And then it's going to go into this monster. So this is the crowder. Right now, from what I'm told, this is the biggest crowder in North America. And this is...
For those that don't know what a crowder is, what does it do?
It's just a giant press that's going to jam those 2 pieces of wood together. So what you're looking at now is the pushing press, and on the other side we have a braking press. And as the extrusion moves through that, it's just going to jam those joints together. And even without glue, once these joints are pushed together through this crowder, you and I, Dave, couldn't pull them apart.
Without glue?
Without glue.
I know I asked this earlier, but I think for the audience as well, what is the tensile strength when you do a joint like that, or a finger joint in that crowder? Does it make a difference in the structural capabilities of that lumber?
No, our joint strength, we test it multiple times daily. Our joint strength is actually almost double the design value of the lumber we're putting it in. So the design value of the 2x4 one embedder we've been making lately is about 10,500 pounds. That's tension perpendicular to grain. I'm sorry, parallel to grain. And our brake tests right now are over 20,000 pounds.
Over 20,000 pounds. Wow. Got it.
So here at the end of the crowder, you'll see those 2 little blue brackets. That is where we are extruding an infinite board. So like I said, if we need 14-foot 1/4 inch, we extrude 14-foot 1/4 inch, and then off to our right here is the flying saw. That saw is going to run back, match the speed of the extruder, and then on the fly, it's going to make that cut with just enough blade allowance left or saw blade kerf to do our final cut on the component saw. The other thing we can do here is we can nest small parts into bigger parts. So for easy math, say we have 4 4-footers, we're going to extrude a 16-footer plus, again, blade kerf, and then we're going to knock that down line a little bit. But the only thing, again, produced here is sawdust.
Nothing but sawdust. Love it.
So we'll go up and over here.
Much better view.
So as that material leaves the flying saw, it's going to go over to the orange rollers off to the left, and then it gets swept up and over this paternoster. That's the big pyramid thing. All that really does is it gives us some additional time for our joints to cure. So our PUR adhesive has an open time of 3 minutes.
Okay.
From the time a board enters the paternoster to the time it leaves the paternoster, you guessed it, 3 minutes.
3 minutes. Wow.
So out of there, we're going to go to one more saw before the final cut.
And I believe you said earlier that this lumber moves faster through this line than what somebody could walk the line.
Yeah, so from the time it's destacked to the time it's going to go to our other robot is about 8 minutes.
Yeah.
So we come out of the paternoster into another automated saw. Now this saw, all it does is it takes those nested parts, those 4 4-footers that are living in a 16, and it's going to knock them down to 4-footers. So again, nothing but sawdust. And then from there, we're going to go to the component saw, and that's where we're going to put the final cuts on our boards.
Got it. So from out of there, all that lumber sliding down what we're seeing here on this tray. Yeah.
All on these high-speed belts.
Oh, got it. That's a belt. I wasn't even looking at that. Right, okay.
Yeah, so all these belts, and they all move at better than 300 feet a minute.
Right.
So from there, you can see again, into the in-feed deck, they get swept over. And then right now, this is the only fully automated component saw when it comes to in-feed and out-feed that I know of in existence. That's the issue with the component saw. They've been the workhorse of the industry forever, but you can't feed them as fast as they run, right? A good operator can maybe hit every other dog when you're running them at 60 flights a minute.
Right.
So all automated, and that's a safety sensitive position. Everyone knows these things have, depending on the saw model, 5 or 6 blades, and the operator's right hand is dangerously close to that primary blade all the time.
Yeah.
So automating that it removes that safety sensitive position. Material comes in, gets cut, and then again, we don't have a catcher. You can see all mechanized comes up out of the component saw onto another high-speed belt, and it's going to go down to our robot. Now, the other thing you'll notice is we have printers everywhere. So we're printing unique part IDs, job numbers, our logos, our mill grade stamp. All of that stuff is getting done in process.
And these are the printers to the right there?
Yep.
Got it.
And we'll walk by it, but off to the right here, you'll see these are all our samples from all our destructive testing. But you can see, here's a piece of 2x4 with a break of 19,444. So remember, design
that's pounds?
value. Yep, pounds in tension. So well over the required 10.5. And then all these smaller ones here are cyclical delamination tests, again, that we're running multiple times a day.
And this is your own testing facility inside here?
Yep, that's our own testing lab. So we have cyclical delam tester, we have our destructive tool tester. We do all of our own sharpening on our tooling for our finger joiners here, so we're not relying on any outside party to continue operations.
Great.
So we'll go up and over one more time, and I'll show you where this process ends.
How long have you been here, Josh?
So I've been with Frametec for going on 18 months. So I came on early. I was Frametec's first hire. I was Frametec's original groupie. So when I came and interviewed with the guys, Marvin asked me, what kind of job do you want with Frametec? And my answer was, I'll sweep the floors. I just want to be on the winning team.
Yeah.
I've been doing offsite. I've been doing vertically integrated framing my entire career. I'm a second generation framer. And once they described what they were doing, it was evident to me that this is what the industry needs and this is the future of framing. So I just wanted to get on board. I didn't care how
And here you are. Now you're the chief operations officer, and I mean, this place is clean. It's organized. You know, everybody you walk by says hello, good morning. The culture's there. Everything that you need out of a manufacturing facility.
Yeah. Well, that's the big part of it, right? Is we're empowering our people, and we're kind of the anti-corporate, right? I mean, we have big aspirations. We want to take this model and stamp it out all over the United States, but it's to solve problems, right? The profit's going to come. Everybody knows that. You're going to be wildly successful if you're out there doing things that industry needs.
That's right.
And we're doing things, a lot of things that the industry doesn't even know it needs yet.
Right.
But empowering our people to go and innovate and meet customer expectations, that's just something that's missing in our industry, you know?
That's right.
And that's why we're doing it different. That's why we're here.
Well, this is definitely different. So if you're out this way in Phoenix or Camp Verde or anything else out this way, I highly suggest you stop by and see what they're doing. And if you're framers out there and you want to see how it's done a better way, not that your skills aren't good, but you're not cutting it to the tolerances they're cutting in here each and every time on every board that goes through. So, all right, let's keep going here. Obviously, we got a bunch of robots to talk about, and we have some other things. Try not to make everybody sick here by turning around.
This is our process end. So you see the big orange KUKA robot there. So as those pieces of lumber leave the component saw, just like we introduced them in, we're going to take them out a layer at a time. So there we're going to accumulate a full layer of lumber. That KUKA is going to come down, grab that full layer, spin it around. On the far side is another set of rollers. We're going to build our packages, and then it's going to get conveyed to the end of this process. Now, a lot of guys in our industry, as you know, Dave, are trying to automate everything from their saws direct to the table. The problem with that is that if you have to change your saw blades, what happens to your fabricators? So we purposely broke our automation to give ourselves some buffer. I tell people, you know, lean, like any other religion, taken to an extreme is a bad thing, and we just don't have the reliability. We're dealing with dimensional lumber. We're dealing with railroads and truckers and all kinds of stuff. We don't have the supply chain certainty that you need to run a process that tight. So we broke our automation, and by doing that, it gives me the certainty that I can go make promises to the customer in the field, because I know even if we have to take scheduled maintenance or, heaven forbid, we have a mechanical breakdown, we have enough buffer in there to where it's not going to affect our near-term deliveries.
Right. Yeah, perfect. And for those of you wondering why we're not running the machines today, it is a holiday here, and it is a day off for everybody, but folks like Josh and a few select others that are here, so everybody needs a break.
Yeah. So from there, our packages are going to go to one of our 6 build stations. So we have 2 Randeck wall panel extruders, 2 Randeck auto-eye systems, and 2 floor truss machines. So what we're looking at here is one of our Randeck wall panel extruders. So quick on this process, we have a term nailer, subcomponent nailer that we're going to build all of our multi-stud components. They're going to come over to a rough opening table where our fabricators are going to build out those openings king stud to king stud. And then from there, all we're doing is we're introducing those components into the wall panel extruder, and the automation is going to take it from there. So as the extruder operator pulls down those elements off the ball transfers, he introduces them into the extruder. And then from there, the extruder is going to clamp the top plate, bottom plate, and then whatever element is next in line, it's going to nail all those elements. So again, nail spacing, straightening studs, all the QC stuff is all happening right here. And then that wall is just going to continue to get extruded out until it's finished. And then from there, we're going to go down to the robotic cell where we're going to sheet that panel.
Got it. So you guys are doing open panels and closed, not a full closed panel, but you're going to sheet the panel at least on one side.
Yep. Yeah. So we can apply any other sheet good here. So, you know, whether it was a zip system or something with rigid insulation on it, we can do all of that. What we really want to do is not get into fully closed panels or get into the realm of any other trade. We want to do the rough carpentry scope of the build better than anyone else and stop there. Not to say that we're not doing a lot of really cool things to help the other trades, but we're working with them, not against them.
Right. And what you mean by that is, I mean, you're pre-drilling all of the electrical holes, the plumbing locations to precision on the whole project. So you're bringing all the trades together. You're bringing the on-site carpenters, you're bringing the plumbers, electricians, mechanical, MEP folks, and everybody's sitting down and making sure that they understand everything that they need to do on that job, and then you sit there and say, all right, well, I'm going to do this, 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 and this for you, so you can just leave your whole saw at home, because that's going to be there, and now you're just going to come, it's cleaner, it's faster, you're in, you're out, therefore dropping costs on them as well.
That's it, right? And that's Offsite's biggest problem is acceptance, right?
Yeah.
So if we're making every trade that follows us more efficient and making them more money,
Yep.
then we're going to get that acceptance. And really, you got to think about it from the builder's perspective, right? If I can frame a house in a third of the time, which we're doing routinely, but the builder still takes 110 days or 120 days to turn the house over,
Right.
we've really done nothing. We haven't done anything for supply-demand imbalance, and we haven't done anything for that builder. But if I can speed every one of those other trades up, and now we can turn that house over in 85 or 90 days, now we've done something, right? Now we've had a real impact on how quick and how cost effectively we can build houses. And now we have every other trade that follows us who loves us, right? So now you're you're fixing some problems.
Got it. So you have two KUKA robots sitting here that are doing the panels, right? And then you have the same thing really on the other side. You just have two different lines going here. One's interior walls, one's exterior walls.
Yeah, you nailed it.
Right?
Yep.
Yeah, so I see it over here. Interior walls, and then we have exterior walls up here.
Yeah, and if we're running the same house simultaneously, exterior walls on one line, interiors on the other, we can complete a house about every 30 minutes.
Every 30 minutes?
Yep.
Yeah, that's fast.
Yeah.
That's fast. And you guys are busy, you said, right now.
We are, yeah. We're looking at really quoting work now into Q3.
Into Q3.
Yeah, Q1, Q2 are pretty much booked up.
Got it. Hey, it's a good place to be if you can pick and choose what you're doing.
All
All right, so that's not the end of it, though. There's more lines here that we're going to take a walk through.
Yeah, let's go check out our one of our truss lines.
And for those of you that are watching this is actually Dave Cooper Old School here. You know, I wanted to come up here since I was in Phoenix to film this, so if it's a little shaky, my apologies. Vince isn't with me. I'm sure he's going to yell at me, though. But this place is impressive. Look at this. Just keeps going.
Yeah, we're 111,111 square feet out here in the warehouse. And that's even a little tight.
Right. So what are we looking at here? This is the truss line?
So this is our Auto I 60. So right now, as far as I know, this is one of one. I think there's another Auto I in Florida, but we don't, we're the only ones that have the automated stapling bridge. So as you can see.
Got it. This is the stapling bridge here then, right?
Yep, off to the right,
Right.
there. So like anything Randeck, absolutely world class. All automated jigging, overhead laser projection that is giving our fabricators exactly where every piece goes. Obviously more important on the internal webs. The pucks give us good exterior lines. So all our fabricators have to do on this thing is introduce the elements in. We're not stapling joints and we're not plating on the table. I can run a 60-foot jig with 3 guys. Conventionally, you'd be 6, 7 guys to run a 60-foot table. 3 guys, because all they're doing is they're bringing the material off the cart, they're putting it in the jig, and then they're pushing the go button on the robot. While the robot's stapling that, they go down to the other setup and they put the material on that jig. So now I don't have guys waiting on automation, they're working in sync, back and forth. The robot staples a truss, it gets ejected, it goes down, staples the other truss, the guys are right back in this jig setting the next one.
Right. Now some of the automation ends though, right? Off this line that we just walked through, but it's different for the robotic line. There's a little bit more manual process. Why don't you explain why you separated the automation of your wood machine that's making the, what did you call it, the infinitely long
board,
piece of board, right? Why did you separate it?
Because we're gonna have downtime, right? Whether it's scheduled maintenance or it's an unscheduled breakdown, something's gonna happen. And what we're not willing to give on is certainty to the customer. A big part of why we're here is because as Kyle Brock, our CEO, traveled all over the United States, all he heard was that they can't get trusses delivered on time, they can't get lumber delivered on time. When they can get lumber and trusses, they can't get their framer. So for us, certainty is a big deal, right? Doing what we promised every day, day in, day out, meeting our commitments is key to our business plan. So breaking that automation gives us the ability to put a buffer in, right? It gives me a little bit of an insurance policy, because it's not if it's or when or not if it's when we have a breakdown, and now we can absorb it without, you know, and then it gives us time to pivot. We have multiple offline saws, we can process material, and then the other side of it is, I mean, you know, we have over $1 million in spare parts on the shelf, but this stuff's pretty exotic, you know. So
Sure.
the potential for a breakdown that takes us a minute to fix is real, and we're mitigating that risk by putting that buffer.
Right. Got it. Got it. Yeah.
So as those trusses are built, pop-outs come up, they lift it off onto the other rollers, and then you might be asking yourself, well, how do you plate that truss? Again, robots.
How do you plate that truss, John? I was just asking that question.
We don't. We don't. We have robots for that. So this big yellow tent that you see out in front of you is where our plating robots live. So that's the actual auto-eye system. The reason for the tent is it's all AI-enabled optical scanners that are going to locate every joint as it moves through, and it needs consistent lighting. So that's why they're big yellow tents there.
Got it. So AI is actually looking and monitoring and seeing that everything was done exactly the way it needed to be done. The plates are exactly where they need to be. So it's kind of the QC of the whole process.
Correct, yeah. So as the truss moves into the tent, the whole tent lights up, it takes a picture and it references or orients that truss based on the drawing it knows it's coming through. And then it's going to take a picture of every joint, and you can see here they have X and Y translations and then plate rotation. So that particular joint had a negative 0.32 degree adjustment. So when the plating robots and the press heads come out, they're making that minute adjustment to make sure that that plate is exactly where it's supposed to go within fractions of a degree. No human can be that accurate.
Right.
Especially repeatedly.
Let me see if I can put this camera through the hole here and give everybody a little bit of a glimpse of what that is in there. We've been doing a lot of Randeck lately. I mean, they're really starting to come up on the scene, being the fact that we were just at British Offsite, right? And the same thing, you know, their manual lines, they had to add 5 extra lines because the automation's faster than the human.
Yep, that's exactly
And that's kind of what you're saying over here too, especially if you have downtime on automation, then it flips a little bit.
Yeah.
Yeah.
Well, and that's why we went with Randeck. You know, we looked outside the United States. Obviously, there's some dominant players here, but globally, Randeck is really the leader.
Yeah.
And this is not. There's not one thing. I mean, we have our proprietary line that's one of one in the world, but even the individual components in that system, they're all proven. Yeah. So there's nothing here that's beta, right? There's nothing here that's brand new that we're testing. This stuff's all tried and true equipment. And you know, Randeck is world-class stuff. Their support's world-class. Their equipment's overbuilt, and you know, I feel better about this. I've run a lot of truss plants in my life, and this by far is one. It builds a higher quality product than I ever thought was possible. Yeah. And two, Randeck engineers come in here, they commission this stuff, start it up, hand you the keys, and we haven't missed a beat.
That's what you gotta love. It's about the service too. When things do, and it's never a perfect process, and that's not a Randeck commercial, everybody.
No.
Right?
No.
Just like I'm not going to make a combi lift commercial down there, but how much do you like your combi lift? Because they're everywhere.
Yeah. Well, and you know, a big part of it is that these companies are listening to the customer and actually providing unique solutions. Right. And a lot of that's domestically, you know, and I will talk a little bit about, you know, all the acquisitions and mergers and really industry consolidation. That stifles innovation, right?
Yeah, sure.
I mean, when you have a dominant position when it comes to market share, what's your incentive to go innovate and get things better, right? It really decreases, and you can't tell me with a straight face that it doesn't. So that's hurt us, and you see these global players coming online and really, you know, putting it to some of these domestic companies, and that's why, you know, there is very little in this whole shop, in this 111,000 square feet that was produced domestically, because these people, our equipment partners from Randeck and Weinig, are thinking outside the box, you know. Tray. I mean, these guys, you know, we said, hey, I need a lineal saw that'll cut up to 6x12, and Walter at Tray said, oh, we can do that, you know. So now we have one of one in the world, a techno saw that can cut 6x12s.
I love it.
And that's what we need from equipment manufacturers, because that's always the limiting factor when it comes to automation is can the equipment do it, right? Can it give the fabricator and the guys in the field what they need? And if we're limited, then we can't meet demand in the market. That's why we partnered with who we did.
Yeah, and throughout Europe, you know, and Netherlands, Finland, Sweden. I mean, this isn't new to them.
No.
They've been working on bringing this technology to market a lot longer than we have here in the States. So we're just helping them up their game here in the States, right?
That's it. Yeah.
Got it. All right, so it comes through these machines. I see you have another Randeck line over there, and so, but what happens is it all goes out to the yard then?
Yep. It all flows outside.
How beautiful it is here, by the way. I don't know, it's probably a glare on the camera at the moment, but it'll adjust.
Yeah. We had a little storm come through last week, but it's beautiful today. So you can see my truck's moving around. So Frametec has our own logistics company. We do drop and hook, so 2 trailers for every tractor. Our turn time in the yard is 15 minutes max.
Yeah.
So that cuts down on reload time, and obviously we can leverage the equipment a little better. So you can see the guys staging, getting stuff ready. That's the other guys that drew the short straw and had to come in to get loads ready to go out tomorrow morning. So.
I know, on the day off. Well, let's talk about this truss stack here in the process, right? Because it's super important. Making things is one thing. Doing it, shipping it out to a job site in an organized fashion is another. So you build it backwards, basically.
Yeah, we do. So the first truss we need is the last truss we build.
Yeah.
And obviously, you know, being the framer, this stuff is way more important to us because we're out there having to handle it, right? So there's a lot of efficiencies that are built when you're vertically integrated like we are, because we kind of see the end from the beginning, and all the way back in the design office, we're making sure that when these trusses go out, how they're stacked, how they're handled, how they go together, that's front of mind because it's our own guys doing it. Yeah. So obviously gable trusses on top, that's the first and last truss you need. And then from there, stacking order is exactly how we're going to roll them on the roof. So whether we're using a crane or we're plate lining these with the pettibone, they're coming right off. We're standing them in place. We had a roof on a decent sized 3,900 tract house, square foot tract house we did last week. I think we had an hour, 30 minutes of crane time just because we didn't have to mess with stacking.
Right,
so
right.
Stacked the whole roof in less than 2 hours.
And look how square and clean and neat everything is on this lumber.
Yeah, and so it starts with our lumber. We went through the QC process. So you'll notice very few knots, if any, minimal to no wane in this whole thing. So QCing the lumber up front, and then obviously the auto eyes, if you look at your plate placement, unbelievable. I mean, perfection.
It is.
It's closer to furniture than it is to framing.
Let me see if I can get a closer view for everybody here. You got my shadow there, my apologies. Yeah. Well, Josh, let's step over this way here with this in the background, and we're going to blind everybody with the light. I'm squinting. You got the nice shades that turn colors. I need a pair of those. So, Josh, anything that we left out that you want to let everybody know out there other than you're doing an awesome job?
Yeah, no, I think, keep pushing, get comfortable with being uncomfortable, and we need this industry to move and move quickly. Depending on whose report, 4.5 to 7 million units behind. We're not going to do it the same way. We need innovation. We need investment in new capacity. We need to break up the monopoly a little bit. So go get it.
Yeah, and I agree. And listen, you're not out there by yourselves. There's companies like Frametec here and Josh, and everybody needs to start talking. There's so much business to be had. He's super busy. This is an example of automation, just like British Offsite and some of the others, where you can do this level of automation and be busy in putting things through and helping build a better future for all of us. So, Josh, appreciate you, brother.
Thank you.
Thank you so much. All right, everybody, if you're not coming to Advancing Prefab in Phoenix, you're wrong. That's where we're going to be tomorrow. Hope you had fun with this live walkthrough interview, unedited. I'm Dave Cooper, and a big shout out to all of our supporting members. We'll see you at Advancing Prefab starting tomorrow. I'm Dave Cooper. Thanks for watching. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you, and as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.